State of the Dolphin is something we did also last year, and kind of funny, I was chatting with the guys tomorrow. I'm also recording State of the Penguin, which is the Linux side. So the Oracle Linux team is in my organization as well, and so I deal with two creatures, a dolphin and a penguin on a daily on a daily basis, 24/7. So it's really great to have these two working together. And in fact, one of the things that we are doing more of now is in the recent years is to have the Linux development team, in particular the tools folks, the folks doing GCC work, glibc work, and so forth, work really closely with the MySQL folks, both on the server side and on the analytics engine side, on the HeatWave side, and do optimizations on the operating system level. So one of the things that we have, I just realized we don't really talk about in the, in the content here, is we have some work done on removing the double write functionality in MySQL by making sure that Linux provides atomic writes. And so when atomic writes are supported by that particular storage for the needs of the server, then we can turn off double writes on the InnoDB side, which is a big performance improvement as well. So that's the type of stuff we're now being able to do by having these two teams, closely co-located as well. So we'll see a lot more of that in the coming years as well. So I have a lot of, a lot of content today. First one is sort of setting the stage as to what we are doing on the server side. You'll see basically two aspects. One is what are we doing on the back end, the server all the way to Lakehouse and all the work on the analytics engine, on Gen AI, machine learning, and so forth. But then also what we're doing on the front end, right? We have a lot of work done for developers and for folks that are building applications so that you have an end-to-end solution. You have the concept we have in terms of how we look at feature planning is you have a mobile phone app, and all you need is a MySQL environment to do everything. The business logic can be in the database, the backend stuff in the database, the analytics, the machine learning, everything else on the backend. So you have one big thing that you talk to, and you don't need more than that. You don't need to set up difficult middle tiers, you don't need to talk to multiple servers and so forth. So that's kind of a very high level vision of what we're working towards. We have most of the pieces in place already today, but we're doing a lot of extra development. So in terms of data platform complexity, which is something you'll hear a lot about for us on the MySQL side, but also on the Oracle database side, right? So we both have a very similar strategy in providing a complete platform that offers a whole bunch of different things. And so, with this build slide, basically, okay, you start with a database, you have some OLTP workloads, then you do some analytics work. So in order to do analytics, typically you have to ETL the data from your production OLTP database because in most cases the OLTP side doesn't support analytics type queries. Then you want to do some machine learning on that data as well. So you have to create yet another setup, do some more ETL from one to the other, make it more complex. Then you have some Lakehouse data, right? You have PDF files, you have text files, you have CSV files. You want to ingest that, and you want to look at data that you have on your database and Lakehouse, so more ETL. Now we have Gen AI in the mix. So in order to do Gen AI well, you have to point to that data, right? You can talk to ChatGPT, but ChatGPT doesn't know anything about your data, right? So you have to be able to provide that stuff too. All right, well, we have more ETL going on. And then you have vector store, so you have your own database, you get your own data that you ingest, and we lose the screen. And then, so anyway, it becomes a very complex mess, right? And we'll take an example of AWS. No particular reason. This could be any other cloud platform provider. It's just easier with them. You need to deal with all these different services. So you have to set up API calls for each of them. You have to learn how each of them individually works. They have their own ways of dealing with user management. So you have to make sure that you don't open or provide access to certain people that shouldn't have access to it. You're putting a lot of data in the object storage stuff. Okay, are we doing this on a public bucket? Oops, you're hitting the register and you hit /dot the next day, right? So doing all these things in different places means it's easy to lose control of where your data is and even just know where the data is. You have different pricing models for each of them. There's a lot of overlap. So you're paying for storage in the database. You're moving that storage over to, let's say, Redshift. Well, you're also paying for storage in Redshift. You're paying for storage in SageMaker. So it really starts to explode. Not easy. We put it all together in one nice little box. You have MySQL database service on OCI with HeatWave, and you get all of this in one environment. One quick API call to set the whole thing up, and you get everything. You get OLTP from the database everyone knows and loves, and you get OLAP, Lakehouse, Vector Store, GenAI, everything within one connection. One way to manage access, one way to manage the users, one way to do upgrades, one way to do backups, one way to do everything. Simplifies it a lot. Also makes it really easy to do reuse of resources. With HeatWave, we build a large cluster that does in-memory processing of the OLAP data, of the analytics data, but we also use that cluster to run machine learning. We also use that cluster to do GenAI. We also use that cluster to ingest data from Lakehouse and then do processing of that as well, all within the same cluster, not 3 services to pay for, everything together. It's a big distinction that we don't often talk about, but that's something that really is important for a lot of our customers. And certainly for folks that have been doing cloud development for a long time. Right? They realize that putting all these things up, setting all these things up separately is very complex. Sorry. One other thing that I was chatting about earlier as well that I wanted to mention is, OCI, one of the advantages we have with our cloud is we are in many regions. Right? We have lots of smaller regions in many countries in the world. We want to make sure we're really everywhere. And there's one is the normal regions, our public cloud, but there's also the private regions for larger customers and for larger partners that want to build their own environments. So they get the same Oracle Cloud deployment uniquely for them. And one of the things that we have as a strategy and a policy is what we call everything everywhere, which is really great from a public point of view. It really sucks for the service teams because we have to literally be everywhere. So every single cloud service that we build at Oracle, we have to ensure we deploy in all the regions. Everyone is required to be in all the regions. Not all cloud vendors do that. A lot of cloud vendors have tons of regions and tons of services, but it's available here and not available here. It might be available in 6 months, it might be in a year. We don't do that. Everything, everywhere, right? And so what that means is you get all this stuff everywhere. So whatever we talk about today, any region in the world that you come from, or any region that we will be deploying next month, in 2 months, in 6 months, will have this stuff. So for global reach, this is really useful, right? And it's something you can build on now and you can rely on. So we have all this stuff, OLTP in the database, HeatWave, the HeatWave engine in the MySQL service provides analytics, provides AutoML, provides the autopilot functionality, which we'll talk about a lot too, provides Lakehouse since last year, and that's been very popular. I think that adding Lakehouse support to the analytics engine was something that wasn't necessarily missing because it took time to develop, but it really kind of rounded out the whole solution a lot. And then you can put anything on top. So you have your applications, your stores. You can use Oracle Analytics service, Oracle OAC if you want to. You can use your standard open source tools or your standard tools that you're familiar with. All that stuff can work directly to one service. So anyway, so that's sort of setting the stage of what we've been working on and the importance of everything in one platform. And like I said, the Oracle database team has something very similar in what they do with the database side as well. So we're very similar in strategy there. So from a technology update, most of what I'll talk about is okay, we had the summit last year, State of the Dolphin 2023. Now it's 24. What have we been working on in the last year? So I could probably, we could spend the whole day just talking about features that we've worked on. So this is a little bit of a summary. Gen AI is very important to us. We've put a lot of effort into that, certainly in recent months, to ensure that we have a great solution, not just a subset of things. So there's three main aspects to it. One is RAG support. The other one is being able to do summarization and content generation. And then the third one is being able to do interaction with the engine. One thing that we did was we embedded an LLM into the service. So a lot of folks have, collect data, have a vector store, be able to put data in the vector store, and then have call-outs to an external LLM to then interact with that and get, more personalized and data back to you or responses back to you. And while that's perfectly fine, and we support that as well, so the ability to make call-outs, we also figured that it would be important to provide and embed a smaller LLM into the database service itself. So you don't even have to go and make call-outs to anything. You don't have to go and set up a separate GPU cluster. We already have compute. It's not as compute intensive to actually do the runtime for the LLM access. And so that gives you a good complete environment in one place. So we can basically, what do we do? Well, we can ingest data from object storage or from the database. We store it in the database in the vector store. We can do unstructured data now as well. So we have the ability to automatically do all this stuff. So we provide all the tools in the service. If you have images, we can ingest an image and process it to store in the vector database, for instance. You don't have to go and do that stuff on your own. We provide that functionality for you. And then we also have the front-end part. So you can basically use us as a ChatGPT service. Even though, as an example, even though you can make a call out to ChatGPT, you don't actually have to do that. You connect to the MySQL database using MySQL shell or something like that, and we have a demo on that as well somewhere. And you can just chat with MySQL. And we have all the data in there. We have the LLM in there. It all stays nicely within the environment. You don't have to do any extra installations, nothing. Just install shell or use an OCI compute node with shell installed, and off you go. You have all that stuff available to you. So one example that we have here is using summarization. So we basically, in this case, ingest a bunch of log files. This could be MySQL log files or something like that. Gets ingested. We have machine learning already in the databases, as I'm sure you're aware, from the HeatWave side, so AutoML. And we can do anomaly detection. So if something's out of whack, there's an error in the log files that keeps coming up or something like that. So we can do that part. Then we go and sort of switch to the other side of the service, which is where the Gen AI part lives. And we can then use the LLM to go and generate a natural language response based on what we detected using AutoML, all within the database. What you would typically do in most cases is you would do the top part in one place, then you would take that data, you would ship it to, as an example, ChatGPT or something else. Then you would create a prompt, or you install the client, you create a prompt, you go and talk to ChatGPT, it then returns a response. So you have to go and do 3 or 4 things. One thing, one interface, one API call, and you're done. Here's an example of the text. So basically, log files would just be a standard feed of text files coming from the database. In this case, it's like an OS. I think this is an OS dump. So you see a bunch of SIG terms in there from a multi-threaded application. And then you can just ask the question in MySQL, what's the problem with this log file? And it'll say, well, there's a bunch of SIG terms in there because you run out of memory. And I guess the OS shoots down the thread or the process. And that's what's going on here. So that's a simple example, but it shows sort of the power of what's embedded in the service right now. As I mentioned, we embedded 2 smaller LLMs in there. We will update them on a regular basis. We might add more. It depends on the ones that are functioning really well and are very efficient. That means they're always available. We have compute that's already being paid for as part of the service, so we just reuse the same compute. You don't get some extra charge from an extra service. But if you want to make callouts to an external AI service, we support that as well from within my MDS itself as well. So if you want to have your own stuff and have things that run, large models running on GPUs, you can certainly do that. I mentioned this before, it's in all the regions. One thing that's important here is, so one is all regions, but also hybrid. So we provide the vector store data type in the community edition as well. So you can basically use tools to dump the data into the MySQL server on-prem, then set up replication to our service. And when you replicate that table into our service, you get all this stuff out of the box as well. So locally, many people typically don't have enough GPUs to deal with this stuff or set up an actual GenAI LLM. And so then you can just basically do replication to the service and you get it without to do any special transformations or learning to deal with a different type of database or anything like that. Where are we? So yeah, I mentioned this. So we have vector data type support. You see it at the bottom, page embedding, vector. All the phases are in there. So what that means is with HeatWave, if you have object storage with a bunch of PDF files and text files, CSV files, whatever, you just point us to there and say, load that data. We then figure out, okay, this is a PDF file. This is how we have to process that PDF file. We generate the embeddings, put them in the vector store. All that stuff's done for you. So you don't need to go and figure out how to parse the documents. We do that automatically. And part of what's really cool about using HeatWave here is that we can do this in parallel. So if you have a 16-node cluster for HeatWave, when we ingest all this data from object storage, we can do all of that stuff in parallel. So the engine in the backend knows how to parallelize ingest and can do it at really, really, really high ingest rates as well. So if you have lots of storage, lots of documents, we parallelize all of that out of the box for you. So with that, we're going to have Sandeep come up and do a quick demo of this, and then we'll continue with the rest of the presentation.
Thank you, Wim. Okay, so let's start the demo. So in this demo, basically what we will show you is that how existing MySQL HeatWave customers can interact with the database in natural language, and we'll show you powerful vector store capabilities that allow you to tailor the LLM's response to your data. So over here, what we have is a Jupyter notebook. Basically, that is connected to an existing MySQL HeatWave DB system. So this is just one example of an application. As we are using SQL, you can basically connect using whatever application you want to MySQL. So as you can see here in the second box, all the APIs that we provide are SQL. So essentially, you don't really have to learn anything new. So all of these are very easy to use SQL APIs. We are leveraging existing functionality in machine learning and enhancing it for generative AI. Similarly, we have also basically added new vector store APIs to allow you to add and remove files to the vector store. These can be PDF files or it can be any of your files. So let's start. So the first thing we are going to do is we are going to load a pre-trained LLM. As we mentioned, we have our own LLMs as well into HeatWave, and then we are going to ask it some very simple questions in natural language. For example, the first question is, why did Estuda, which is a MySQL HeatWave customer, pick MySQL HeatWave? And the thing to remember is that these are questions right now based on the LLM's public knowledge. So there is no vector store involved. And as you can see here, the answer is very generic. It was the best choice. That doesn't really tell me much, right? It's not a very good answer. Now the next question we are going to ask is, what are the benefits the company Tetris.co, which is another marketing company based out of LAD, achieve using MySQL HeatWave? The LLM just repeats the question. So this problem in LLMs is called hallucination, where the LLM itself doesn't know what it doesn't know. So it just outputs an answer to you, right? So now what we are going to do is to improve the quality of our answers, we are going to ingest these custom or these enterprise documents, so information about Tetris, information about Estuda into the database. So this is the vector store functionality. So now we are going to ask the same question, why did Estuda pick MySQL HeatWave? So now the LLM has context from your data. These are PDF files, HTML files, docx files, whatever. And essentially, now the LLM gives you a very good answer based on superior query speed, on-demand scalability. Estuda quickly expanded its business, right? So this is a much more contextual answer based on your data. And as you can see, the interface is very simple. Everything is happening within one system. All of this, your data doesn't move. Similarly, the next question, what are the benefits the company Tetris.co achieved by using MySQL HeatWave? You can see the answer here compared to the earlier answer, just something, right? Because it enriched the service, it basically improved the query execution time from minutes to seconds, the engagement increased with executives, and essentially customer engagement got deepened, which improved customer loyalty and attracted new customers. This is a much more accurate answer and it's based on your data. And similarly for the last answer, which is also true, a lot of HeatWave customers have migrated from Aurora and Redshift, right? And actually they have massive cost savings by almost 50%. And the LLM basically is able to come up with that answer because it got that context from your data. So the demo essentially shows the powerful natural language and vector store capabilities of MySQL HeatWave and how you can tailor responses to your data. Thank you.
A few things on this. So one is you don't need to set up separate API keys, make REST API calls to a different service. It's just your standard SQL statements that you're already doing. So the same user, you know who has access or doesn't have access. Very important. The second thing is, I think in general, Gen AI is very popular and it's kind of cute for personal use if you use the public services, but from a company point of view, you need to be able to provide your own data to it. Otherwise, it doesn't really provide a lot of benefit, right? And so by being able to do this within the database, you can set up, one of the projects we were playing with as an example, we have all the MySQL support files, the documents that we've written for support purposes for customers. We have all the documentation in PDF format. Within 5 minutes, we can create a SQL-based, MDS-based solution where we just say, here's the object storage bucket that has all our documentation and our text files for documents for customers. Read it into the database and use the chat API inside the database to do support queries. So if you have a company where you have products and you have tons of documentation, within 5 minutes you're up and running. You have your own chat client built within the database. That's it. It's all right there. You don't have to go and create another service. You don't have to do your API keys, nothing. It's all right there for you to use out of the box. So that's Gen AI. We started with that because it's such a popular topic these days. Everyone has to deal with that. But we do a lot more than just Gen AI. On the OLTP side, we've spent a lot of work on HA. So as most of you probably know, the way we do HA is we basically have 3 instances, primary to standby. So if the primary for some reason fails or during upgrade processes, then we switch to a secondary. We set it up so that it's in different availability zones or full domains if it's within one availability zone. Primary is the read-write, and then we can promote a secondary as becoming the primary if something happens. And so that allows you for doing failover without any data loss. On the scalability side, we've added a lot of support for read replicas. So you can have up to 18 read replicas set up automatically with one button click on the service. There's a load balancer in there, and so we do hashing to make sure that we go to the right instances. And very importantly, we spent a lot of time on improving bulk ingest. We were a little bit behind our competitors in terms of being able to ingest lots of data into the MySQL service. And so we sped it up significantly, a lot of parallelization. On the data protection side, standard stuff that I think you would get everywhere. We've made it easier for operators to be able to do things on backups, to periodically see if a backup is actually in good state so that you don't end up with surprises. We have improved point-in-time recovery a lot, and a lot of work done on patches. The standard stuff you would get from a cloud service, but we put a lot of effort in improving these things on a regular basis. HA is completely built in, as many of you know. So when you provision a database, you just have the HA button on the OCI console, and it sets up the whole instance for you. Bring your own certificate is something we've introduced that was a very popular request by lots of folks out there. So we fully support BYOC now in the service. HA improvements. So I wanted to spend a few minutes or a few seconds on this one. So planned upgrades and switchovers. where we were monitoring these things, obviously, and they were pretty high. And so again, the team put some projects together to improve that significantly. So we went from 60 seconds to 15 and 7, and we still have some work to do to get it even lower. So it's really important to us because we know that it's important to you that we reduce that as much as possible and bring it as close to 0 as possible. So we've done quite a bit of work on it in the last several months, and there are more projects happening here as well. And then another thing that we've supported now, or we started supporting, is being able to change the shape online. So if you have a secondary, we can change the shapes from an 8 core to a 16 core. You don't have to go and re-provision the database or create a new one. And also changing the configurations of the HA cluster. So that's something that we introduced just recently. Same with read replicas. What tends to happen is some of our customers have, let's say, 5 or 6 read replicas, and then one is used for a very particular workload, and then the other ones maybe for smaller ones. So you can actually change the shape. So you can say, okay, we're going to have one replica for this thing, and then a bunch of other ones for smaller ones. So you can balance how you want it and what you want to do with it, and supporting different versions of the server. So if you want to test your application against a read replica with a different version of MySQL, you can actually do that now when you set up the read replicas as well. Point-in-time recovery, again, most of the focus has been on performance, especially when you have large databases. When the bin logs get really large in size, we've reduced that drastically in being able to do ingest on the database. So. Autopilot. So autopilot indexing, we have a feature, I think we talked about this last year, did we? So basically automatic index creation. Well, we don't automatically do it for you in the background. You run a script. We say, well, we think that you should run these index create and delete statements, and it will improve your application. We generate a SQL for you. You can just cut and paste it and then run it. So we're not doing it in the background without you knowing. We're just suggesting it. But it is based on machine learning. It's based on us collecting lots of data and lots of statistics while the database is running. So then when you say, okay, I've been running this app, I have 50 indexes on it, can we reduce that, save some storage space? And it will say, yeah, you can drop these 20 indexes if you create this one here, and you do it. And we've had really, really good success with this. We're doing more work on it, but it actually has been very successful. So it's automated in terms of advice, not in terms of creation. You have to do the create. And we might end up providing a button someday where we say, hey, if you trust us blindly, just push this button, we'll do it for you. But we don't have to do that. New operators, so we do keep enhancing the server side with new functionality and new operators as they become more interesting. So here's a bunch of them. So keep making sure that, you know, we certainly in the space of analytics, we want to make sure we support standard operators. Price performance, I'm not going to spend a lot of time on this, but we are significantly lower cost than anyone out there, and in most cases, significantly faster as well. So, adaptive query execution is something new. Because we have the HeatWave engine and we have been working hard on the optimizer in the server, we can now basically use the HeatWave engine to collect statistics, and while we are executing a query, basically change on the fly how we are doing execution. So it's no longer just static. If the optimizer during the big query says, oh, actually this would be better, then it'll just switch to that on the fly, and you get a better performance out of your query on the fly. So that's something relatively new. We've had great success with this ourselves when we run all of our test suites and benchmark data, TPC DS, TPCH, and so forth. It really makes and also with customer live data, not just our own data. So that really has done a lot of improvement, and especially in as it says here on the slide, in the first run. So when you get new data in, we don't really have all the statistics necessary. We don't necessarily know the best plan for that query yet. Well, we can do it on the fly and sort of get you the best performance as quickly as possible out of the engine. Auto load and unload. So for those that have used HeatWave before, one of the things was that in the beginning, you had to specify which tables you wanted cached or mapped into the HeatWave engine so that we can do processing on it. We now support full automation on that. So if there are certain tables that should be in the HeatWave engine in memory, then we will figure that out and do it for you. You don't have to really tell us much anymore. We've automated that process, which will make analytics a lot easier to use as well. Compression. So we always look at things from, or Nipun's team, not me, certainly his team. They're the wizards here. There's two things that they look at. One is how can we optimize for cost and cost savings? How can we do more within the same amount of time? And then of course the other one is how can we be faster, right? We always want to be the fastest. We don't want to give up performance for cost. It's a balance that we play for each of the features that we work on. So when we use compression, we can store more data in the engine. Well, that means we can, process more data within the same footprint, so you pay less for the size of the cluster. If we can store 1 terabyte in a server instead of 700 gigabytes, well, that's 300 gigs of storage in memory that we can do for you without paying for more storage. But if we can do more in one engine, then we can also be faster because we can process a terabyte of data because it's compressed in memory. So it kind of balances in two ways. And with adaptive compression, we have support for different compression algorithms, and we use the right one for the type of data that's coming in. Support of semi-structured data. So JSON support is obviously very important, and that is added as well. So you can have JSON data stored in the different file formats we support, and it will be able to be parsed directly into the HeatWave engine. In database machine learning, this is enhancements on top of what we already did last year. So AutoML has added more support for different types of algorithms. We do anomaly detection, forecasting, the recommender system, which has been very popular. So you can build your own Netflix engine within MySQL, just like that, basically, right? Or like classifications and loan default. So whatever type of data, we have some form of algorithm for it in the database to support doing ML on it. And we support that on lakehouse data. Very important to point out. If you have all this stuff in PDF files or whatever, we ingest it into the HeatWave engine, and we can run AutoML on data in the database, data in lakehouse, both of them. Some different use cases. Not going to go through all that. Data drift monitoring is actually quite important. So when you run training on your data, or you process the data, when you add more and more to it, at some point that training model is out of date. How do you know when to rerun the training on the data you have in the database, right? So with the data drift monitor, we basically detect that, and we'll be able to tell you, or we tell you, you probably want to rerun training on the data because it's skewed so far from where it should be that it's no longer going to be as effective. So you don't have to wait for customers or other people to say, hey, this stuff is no longer right. We can actually tell you up front, hey, you're drifting away from what it should be, so you might want to take some time to run the training on your data. So that's also embedded in the engine now out of the box. Anomaly detection, kind of talked a little bit about that before. We use some of this ourselves as well, obviously, for the service. So when we see things happening in the service that shouldn't happen, then the operators get notified as well. So I talked a lot about Gen AI in cloud, about the cloud service, so now it's time to talk about the server itself. This is probably the number one thing that we did and decided to do that was a huge request for customers. So we now have a long-term support release for the server itself. And so 8.4 is the version that we picked. And this will be supported for 8 years as the release for MySQL for long-term support. So we will obviously continue with newer versions, MySQL 9, and we will keep doing new releases, and those are sort of the feature releases where we put all the new functionality. But if you're stuck on a certain version that you want to not have changed, no new functionality, just fixing critical bugs, then LTS will basically remain flat and frozen for a long period of time. And if you want to be on newer versions, then you can certainly obviously do that. The newer versions, yeah, we call them innovation releases, and so that will continue at a rapid pace, once a quarter, but they will evolve more quickly. JavaScript stored procedures is also something we talked about last year. We actually already have a production customer for this as well. So basically, aside from standard SQL functions, you can now just embed JavaScript in the database, create your own functions written in JavaScript, execute SQL statements from within those stored procedures in the database. You don't need to go and create a middle tier for this type of stuff. It all just works out of the box. And one of the things that's important is that we also support this for Lakehouse. So if you have PDF files in object storage and you ingest them using HeatWave, you can write JavaScript in the database that operates on data coming from your Lakehouse data. So processing stuff from PDF files or whatever else. So that's been a big advantage. JavaScript is the first language. I'm not going to commit to particular other ones, but what we've done is we've embedded GraalVM, which is built by Oracle, the Java team, and the Graal team, which is a multilingual virtual environment, a VM, a language VM. So it can run Python, JavaScript, Ruby, Java, and it can run all these things in parallel. We can share context between the different languages as well. I'm kind of pitching GraalVM here, but basically you can write Python and JavaScript running within the same GraalVM engine, and then you can basically share context between the different languages and make callouts from one to the other, staying within that environment. So that's what we took, and the Oracle database did as well, and pushed into the server. We took JavaScript first, but it allows us to, in the future, also add support for different languages. So potentially Python support in the database, potentially Java support in the database is something we can certainly do now. It's just a matter of enabling it and testing it. Thread pools and performance on thread pools. So basically pooling multiple connections into single processes or threading it to have better scalability, basically, instead of doing one-to-one. Accelerated development, so a few moments on the developer side, which is obviously very important as well. So one is MySQL Enterprise Edition has a lot of functionality that's not necessarily in Community Edition. And so at Oracle, we have, ever since the early 90s, it's been, it's like 30 years or so that we have OTN, Oracle Technology Network. And all Oracle products have always been available free download for developer use. Anyone can download the Oracle database or any other product and use it for developer purposes for free, with all the functionality included. And so we finally added MySQL to that as well. So you can download MySQL Enterprise Edition from Oracle.com with all the functionality that's in EE and use it for developer purposes, test and development purposes for free. So GraalVM is an Enterprise Edition. Just download it, run the binaries, and you can use it as much as you want to. So that's one of the things that we've added as well. It includes router, includes everything. VS Code is, of course, a very popular editor for developers, but it's also a great platform for the tools developers to build out their UIs for the different backends. And so the MySQL shell team has done, or the client team has done an amazing job at having MySQL support in VS Code. All the different features are in there. We're including GenAI. So if you want to do a GenAI chat call out from the shell, you can do that. If you want to ingest data from Lakehouse, you can do that from here. It's all nicely embedded. And one of the things that, if you haven't used this yet, one of the advantages with how this is implemented is, let's say you use OCI, and you have your laptop and you're, I don't know, you're traveling, you're at the airport. Well, Shell will use the OCI Bastion host to create an SSH tunnel to your database running in OCI. So from your client, without having to set up VPN tunnels or IPsec tunnels, your VS Code session can make a direct connection to your cloud database without you having to put your cloud database on the public internet. Because what we do with the service is it's running within a virtual network inside OCI, and then it's not exposed to the outside world, right? And so how do you do development if you're somewhere, or even if you're just at home? You have to set up all these tunnels and stuff. Well, you don't have to do that with us because we create them for you in the backend with your OCI credentials. It's a feature that I don't know many people know of, but I think it's quite powerful to use. The operator, this is not new, but just so you know, we have a very good, well-maintained Kubernetes operator for the database. And then also the REST service. So MySQL router has full support for creating a REST front end to your database. So you have a bunch of tables, you have an app that you have like a single page JavaScript app running in a browser or some PWA app on your phone, and you want to talk to the backend database. Well, you know, instead of having to set up some middle tier and create like a, I don't know, like a Python Flask thing where you set up all your API calls, you ingest them, then you have outbound calls to the database on the back end. Easy to do, but it takes you a while to do. And all you want is access to a certain row in a certain table. Well, with Router, you just push a button, you have Router running in front of the server, and you have REST API calls. Full support for OAuth 2. So your client is a standard client. It talks REST API calls to Router, and it talks to the database. We deal with all the mappings of the SQL statements and the data in tables and map them back to REST API calls. Very simple, no need for any extra stuff. And the VS Code plugin has a really great UI for helping you build out all these things. And then lastly, a section on observability and management, which is obviously also very important. So one of the things is we've started with adding support for tracing to the server, and we use standards, right? So we use the OpenTelemetry standard to emit or expose traces and logs and all that stuff from the server, from the client libraries, so that you can use your own tools if you want to. So if you have some standard installed, yeah, CNCF has a bunch of projects on this. We have our own services, so the application performance monitoring in OCI and logging analytics in OCI can ingest OpenTelemetry data. So you can use our own services or third party, doesn't really matter. But there's standard ways to collect data from the server and from the client so you can see how your application is doing. And as we do more of this end-to-end stuff, this becomes more important, right? Because you have your client app, again, a mobile app that talks to the database, and you want to know whether when a customer calls and says, well, my app is slow, where do you start? Well, the app will emit some OpenTelemetry data. We use APM to detect, you know, your API call from the client app to the REST server took long. Well, maybe it's the network locally. Or your call from the router to the database took a long time. Well, maybe your database is slow. So we provide you with all that telemetry and in a standard way. We also included the database management support for MySQL now in OCI. So if you haven't used that yet, it's very powerful. It supports both on-prem databases and OCI databases. So if you have MDS in OCI, or you have the agent installed on-prem on your servers, or on third-party clouds in a VM with a database, then we can manage the whole thing. You get a fleet view, you can create subsets, you can use all the standard constructs that we have in our cloud to do management of MySQL databases. Perf Hub is in there, so you have performance issues. We provide a lot of data on SQL statements that are performing or underperforming as well. It's all in the same platform. We support the insights, the predictive and SQL insights as well to show you know, when things are starting to slow down or something like that. Enterprise Manager has a MySQL plugin that we've been updating so that it's current. And Enterprise Manager is used, a lot of our customers, I don't know how many of you here do this as well, but a lot of our customers use both the Oracle database and MySQL. And so EM, Enterprise Manager, is the tool to use for Oracle Database. And so by having the MySQL plugin there as well, you have one management platform that deals with both. And EM is a really comprehensive platform that does alerting and has all the history and stuff like that. So combining the two is quite powerful. And with that, just a slide of, MySQL is used in every industry, in every form of what you do, whether it's social media or back-end manufacturing, inventory management for car manufacturers, or even just the assembly line for a car, something like that. Even that stuff is done in MySQL databases. So it's used everywhere. It's very popular. Yes, we have obviously competitors, and we are well aware of the comments they make and such, but we have a lot of good stuff going on. We're clearly very committed to this. I hope that if you were here last year and you see all the work we've done in just 1 year, that this is not something that's slowing down. If anything, it's been accelerating in the last 2 or 3 years, right? It's just, there's so much new stuff coming. We're adding more people to the teams as well. We're focused on cloud, but as I said last year, everything we do for cloud is something that also helps the server, right? We are the users now as well. We're running the database for our customers in cloud. We have to improve the server for diagnostics so that we can be faster at dealing with that. We have to do stuff on the server for performance. That all goes into the generic server engine, right? So even though you might say, oh, Oracle's focused on cloud, yes, we absolutely are, but a lot of that work also goes into MySQL Server that you can run on-prem. One advantage we have is with the HeatWave engine, we can use all that data and do more stuff that you just cannot do on-prem. Right? That's the advantage of being a cloud vendor with owning a product like this. So that's all I have, and I probably ran over time a little bit, but it's a lot of stuff. I hope you enjoyed this. Have a wonderful day, and thanks for being here. Thank you.